Hello everyone, this is Mrs. Kulkarni, lecturer, Department of Physics, KLS Kokte PU College, Belgavi. In continuation with my earlier video on electrostatic potential and capacitance, that is second chapter. So this is my third lecture from the same chapter. I am going to discuss few more concepts from the same chapter which are very important for 3 marks. So some derivations I am going to discuss in this video. First one, derive the relation between electric field and electric potential, or derive E is equal to minus dV divided by dx, which is very important derivation for 3 marks. Okay, so frequently they in the PU board annual examination they have asked this question for 3 marks. Okay, so this is very simple and easy derivation. Okay, consider now, suppose if we consider the charge, positive charge plus Q. Okay, then what is the electric field? So electric field is in this way. Why? Because this is a positive charge and electric field line is always moving from positive terminal to infinity, right? So this is the direction of electric field. A and B are 2 points. Okay, so here also I mentioned let A and B 2 point separated by distance dx. So distance is dx. Okay, in an electric field, and these are all imaginary, we are assuming. Okay, so positive charge is present, may be present. Okay, so A and B are 2 points, they are located on the electric field line. Okay, so we are assuming all these points. Okay, Q naught is a unit positive charge placed at A. Q naught is what? It is a positive charge which is having very negligible magnitude. Okay, so we are just bringing this charge nearer to this, okay, to understand whether there is a electric field of force, electric force and field we are studying. So this is another charge. Earlier where it was we don't know, so we are assuming maybe it was at infinity. So we are bringing this Q naught charge from infinity to point A. Okay, then dV is the potential difference between A and B. What is potential difference? We discussed already in the previous videos. Okay, dx is the distance between A and B. So this notation means what? This is the distance between A and B. Now dV is equal to work done in bringing Q naught charge from A to B. So this expression also we discussed in the previous videos. Okay, please go through the previous videos. Okay, so potential means what? Work done. So when we shift one object from one place to another place, then what we say? Work has to be done. Here also, suppose if we bring this positive charge from infinity to A, whether work is done or not? Definitely there is a work done. Okay, as well as in presence of electric field we are performing this work. Okay, so definitely there is a work done because there is already a force here due to this charge. Okay, so electric field is present already here. So we are bringing this unit positive charge or negligible magnitude charge we are bringing from infinity to A. Then definitely there is a work done. Suppose if we shift this charge from A to B, if we replace this charge from the position A to B, then what is the distance? Distance is dx. Okay, if we shift this A to B, whether work is done or not? If we are moving from A to B, this charge means definitely there is a work done. Okay, I hope this diagram is cleared. Okay, whatever points I mentioned here, so I hope you understood all these points properly. Now according to this formula, dV is equal to dW means work done in bringing unit positive charge, that is Q naught, from A to B. Earlier it was at infinity and I shifted, okay, I am just assuming this, I am shifting this charge from infinity to A, then A to B. Okay, suppose if we shift from A to B, then what I have to write here? Q naught charge from A to B. We are shifting this charge from A to B. Now dV is equal to dW divided by Q naught. Then next, what is work done? Work done is nothing but force into displacement. This is the general expression. So substitute here F into dx. F is force, dx is displacement. Here displacement between these 2 points. Okay. Then Q naught as it is. But why negative sign? Negative sign indicates that the field and displacement are in opposite in the direction. So where is our electric field? This is the direction of our electric field. What is the displacement? We are shifting the charge from A to B, means this is the direction of the displacement. Both are opposite. Okay. Both directions are opposite here. Electric field and displacement. We are shifting the Q naught charge from A to B. So the direction is opposite. Okay. Displacement direction is opposite with respect to this electric field. That is the reason minus sign. Okay. Then dV is equal to minus E dx. Why E here? Because we know that F divided by Q naught is equal to E. Already we studied this expression in the previous videos. Okay, please go through this. So F divided by Q naught is equal to E. So substitute the value of this E in this expression, then simplify. After simplification, therefore E is equal to minus dV divided by dx. Okay. So shift this dx here and negative sign here. Then what we get here? So E is equal to minus dV by dx. So this is the final expression for what? For the E. This is the final expression. Therefore E is equal to minus dV by dx. So this is very important derivation. Okay, very simple and easy derivation. Okay. Second one, electric potential energy of a system of point charges. Potential energy of system of point charges is the work done in bringing them from infinity to given positions. Same type of derivations here. We are assuming the 2 charges. We are bringing them from the infinity. Okay. Same procedure, the same whatever we studied in the previous slide, same type of a study, but here what we are studying, expression for electric potential energy of system of 2 point charges in the absence of electric field. So when we say that electric field is present, suppose if we keep one charge in some space, then this space is called a electric field. How we come to know? By experiencing the force. Okay, then we come to know that this area is called a electric field. You just imagine in this case, charge is not present. Okay, charge is not there. Suppose if the there is no electric field, then if charge is not there, then definitely there is no electric field. If only space or area is present, there is no charge, empty space, then is it the electric field? Definitely not. Okay. Then if we are bringing the charge from infinity to the particular point like A and B. Okay. First, in the first case, suppose if we bring only one charge from infinity, and where I am going to fix? I am going to fix at a particular point. So that point I denote by A. Okay. Earlier where it was at infinity. We are bringing this charge from infinity, and where I fixed at A. Okay. So in the empty space, if I fix this charge, now there is a electric field. Earlier before shifting that charge, there was no electric field. This is open space. There is no electric field. Okay. When I fix the charge at this point, now the area is surrounded by the electric field. Because of what? Due to this charge. If I bring the charge in absence of electric field from infinity, is there any work done? Definitely not, because we studied in the previous slide that the work is done but in presence of electric field. Like that we discussed. Okay. Work has to be done. When it is possible? If the electric field, if it is present, then only we say that work has to be done. When we bring the charge from infinity to the particular point. Here there is no electric field. This area is empty. Okay. Suppose if I shift the charge at this point, then there is no work done. Work done is 0. Okay. So no electric field to oppose this charge. That is the reason work done is 0. There is no work done. Next one, for the next condition for point B, okay, here in the first case Q1 is brought from infinity to the point A and no work is done in this case. Okay. For the second case, consider another point B at a distance from A. Okay. Then the electric potential B due to Q1 is given by, this is an expression. Okay. Let us understand first the diagram. This is another charge. Again, if I bring that charge from infinity and if I fix that charge from infinity to B, okay, already one charge is present here at A. One more charge if I bring and if I fix that charge at point B, then there is a work done. Work has to be done. Okay. Why? Because due to this charge, the surrounded area is called electric field. This area completely occupied. This is electric field. Okay. So that is the reason. Due to this charge, electric field is present here. If I bring one more charge and if I fix that charge at B, definitely there is a work done. Okay. So the distance between A and B is R, and these are two charges denoted by Q1 and Q2. Okay. Now the electric potential formula V is equal to 1 by 4 pi epsilon naught Q1 divided by R. Okay. So already we discussed the electric potential formula in the previous videos. Okay. What is that? V is equal to 1 by 4 pi epsilon naught Q by R. This is a general expression. Okay. But here I mentioned V1 and instead of Q, Q1, because due to this charge, the electric potential due to this charge is V1 is equal to 1 by 4 pi epsilon naught Q1 divided by R. Okay. At this case, at a point A, in this case, work done is 0. Again, one more time, if we bring one more charge from infinity to, and if I fix that point charge to B, then there is a work done. Okay. That charge is denoted by Q2 because there is a electric field. Okay. Why electric field? In the presence of the charge Q1. I hope you understood the diagram properly. Okay. Now suppose if we substitute the values according to that explanation, work done is equal to potential into charge. This expression also we discussed in the previous videos. Please go through that. Okay. So W is equal to V1 into Q2. Okay. Why? Because V is equal to W divided by Q naught. That implies W is equal to Q naught into V. So this is Q naught into V. Okay. Now what is V1? Already we discussed what is V1. V1 is nothing but what? V1 is 1 by 4 pi epsilon naught Q1 divided by R. Okay. Substitute that value in this expression. Then V1, instead of V1, 1 by 4 pi epsilon naught Q1 divided by R into Q2. Q2 as it is. Due to the second charge it is. Total work done. In the earlier case work done was 0. For the second case work done is equal to how much? V1 into Q2. So this work done is stored in the charges as potential energy and is given by PE. PE means potential energy. So work done is nothing but what? Stored energy. Okay. So it is in the stored energy of stored in the charges as a potential energy. Okay. Work done is stored in the charges as a potential energy and it is denoted by PE. PE is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R. Okay. Where R is the distance between the charges. Okay. So this is the final expression for what? For the potential energy. Okay. Final expression for the potential energy. So work done is nothing but potential energy, which you already studied. Okay, you might have studied in the school level. Okay, and both are having the same SI unit. Okay, so here we are using the same concept. Okay, for the charges also. Work done is stored in the charges. Stored means what? Definitely potential energy. Stored energy is nothing but what? It is a potential energy, right? And R is the distance between what? Between the charges. This is very, very important derivation. Practice this many times. Next one, third one, expression for electric potential energy of system of 2-point charges or 2 points in an external electric field. Suppose if electric field is present, then what is the condition? So here this is Q1, Q2, two charges are present here. Due to this Q1, potential is V1. Due to this Q2, potential is V2. Distance between these two is R12 and these are 2 points A and B. Okay. And this is the direction of electric field. We know that these are the positive charges. So outward direction we have to show. Q1 and Q2 are the magnitudes of the charges. V1 and V2 are the potentials at the points A and B respectively due to external field E, and R12 is the distance between the charges. Okay. Then we discussed already PE means potential energy, where the work is stored as a charges in the potential energy, right? So PE is equal to, PE means potential energy. Potential energy is equal to total potential energy is equal to potential energy of system of two charges in the absence of electric field. Before shifting these two charges, what is the potential energy? Okay. First one. Second, potential energy due to the Q1. Due to this Q1. Potential energy due to another charge Q2. That is this one. Okay. Then potential energy of system of charges in the absence of electric field. Just now we discussed in the previous slide. This derivation we discussed before this slide. That derivation already we derived. So what we got from that? 1 by 4 pi epsilon naught Q1 Q2 by R actually. But here instead of R we have taken R12 in this case. So instead of R, R12 due to what? This was first and second charge Q1 and Q2. So here I mentioned R12. Okay. So this is in absence of electric field. Already we discussed. Okay, this is the potential energy of system of two charges in the absence of electric field. This expression, this is the expression. Same expression I am going to substitute in the next derivation, that is PE of system of two charges in the absence of electric field, right? The next one, PE of Q1 at A, that is Q1 into V1 plus PE of Q2 at B, that is Q2 into V2. Okay, so this is the final expression. So these are the expressions for the potential energy due to the two charges in the presence of external electric field. Okay, this is also very important for 3 marks, 2 or 3 marks. Okay, and practice all these expressions. Those expressions will help you to solve the numericals. And here I prepared few questions based on these slides, okay, to check your understanding. Okay, so very simple questions. First one, expression shows is the relation between the electric potential and electric field. Second one, expression for the work done is stored in the charges as a potential energy and is given by dash. Expression for electric potential energy of system of 2 point in an external electric field dash. So pause the video, cross verify your answers with my answer. Okay, so you just go through these answers. First answer is E is equal to minus dV by dx. Okay, so first derivation which I discussed, relation between electric potential and electric field. Second one, second derivation, okay, expression for the potential energy in the absence of electric field. One, that is PE is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R. Then third one is third derivation. PE is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R12 plus Q1 V1 plus Q2 V2. Based on those three derivations, I just prepared these questions, and please remember these expressions. These will help you to solve the numericals. I hope I have cleared your doubts. If you need further questions and answers from the second chapter, please go through the link given below. Thank you.